And I'm very happy to introduce Carol Wilson. I checked the schedule. I know who's up. Taking us from salt marshes to warmer places.
Yeah, thanks so much. Can you guys hear me okay out there? Okay, great. Well, welcome to LSU. I'm actually a professor here in the Department of Geology and Geophysics. And it's been great to hear everyone's talks that have come through because I'm an observational ecogeomorphologist. So like what Kendall was talking about, I like to provide the data for you all that you all can then plug into models. So it's great to be in a room with some folks here. And I just want to shout out a lot of the work that I'm going to show you today. It comes from my PhD student, Jeff Bomer. He was here a few years ago. I also work with Sharmeen Akhtar at Dhaka University. And then without Abu Nasser Hussain, he works for the forestry department, we would never have gotten access to be able to go to this area to begin with. But Jeff was very interested in thinking about carbon sequestration in this particular mangrove. And that's how we brought Tracy Quirk on board, because I only know enough about carbon to get myself in trouble. So we were able to bring her into this. So the Ganges-Brahmaputra Delta, it's where these two river systems coalesce and then discharge into the Bay of Bengal. We heard some great talks yesterday that really highlighted this. I do want to bring to light that it's important to look at DEMs, the digital elevation models, to really help us understand where the fluvial-dominated regions of the Delta versus tide-dominated regions. And when you look at this DEM, there's a topographic break that occurs in the elevations. And this is also where the tides can incur. So as what Mead was talking about before, with tidal modulation, this would be essentially these variations in the tide can extend over 100 kilometers inland. And then salinity incursion, during the monsoon season where the majority of the discharge is happening, all of this is fresh. But it's only during the dry season that there's what we call the moribund portion of the Delta, because it's not directly connected to the Ganges or the Brahmaputra. It's receiving a ton of water, that's saline that incurs into that area. And for this group, I wanted to point out our peat basins. Many of you may not know that in the past, there were some extensive peat basins that existed in the distributary basins right along that nexus of the fluvial and tide-dominated areas. And they were dominated by reeds or C4 grasses. Unfortunately, you can't see these anymore because of anthropogenic modification. They mined these for the peat to use them for energy. So a lot of our low-lying regions of the Delta are actually occurring right there because of that excavation of the peat mining that's occurred. What else do I want to show you here? So if you think about then this lower Delta, this would be where most of the mangrove forest would extend. But over time, because of humans modifying and moving to these areas, deforesting, the only bit of the mangroves that exists now has been preserved in the Sundarbans. Here's some pictures of it at the top. And then the remainder is the poldered regions that surround that area. So the tidal modulation is great. So here's one area in the northern portion where it's about a 3.5 tidal range. You can see at high tide, the platforms are getting inundated. And then at low tide, this is important. I do want you to take note of where the water levels are in that channel. They are meters lower than the high tide platform. If anybody's interested in suspended sediment concentrations, I've got some great colleagues with some good data from what's happening in the channel versus when those platforms are flooded and what happens to that sediment. Many of you may not know the Sundarbans is named for the shundri tree. This is an example of it with its beautiful flaring base and the pneumatophores at the bottom. I'm just going to kind of set the stage for sea level rise for this delta here to talk about our tide gauges that have been accumulated here along the coastal region. Many of them show about an average of 5.5 millimeters per year for relative sea level rise. Again, this is a deltaic region. This is not only eustatic sea level rise, but we also have subsidence from the load of the sediments that are happening there. But I want to bring to point, this is calculated using mean sea level. So they take all of those tidal ranges, spring, neap, high, low, average them out to get this. What's been happening of late is that we realize in this delta, it's the high water levels that are actually building those platforms, and it's really what the high water levels are doing that we need to be looking at. So there's been some important concepts of something called effective sea level rise, which is the rise in high tide water levels. So if we're only looking at the high tide, what it's doing over time and how fast that is moving. So some great work from Pethick and Orford and Van Maren really show these rates are about 7 to 20 millimeters per year. and that the rates are really, really high in those areas of the polders that are further inland. Okay, so what the work that we are doing is a lot of my lab, we're looking at the elevation dynamics of the polders versus the Sundarbans. We use what's called our rod surface elevation table with marker horizon. Andre was mentioning a bit of this yesterday. We have them coupled in the Sundarbans for stream bank and interiors, and then also within the polders. For today, we're only going to focus on the Sundarbans region. And I'm going to highlight, we're mostly got some sites up here in the northern Sundarbans. This is our longest running set. Although if you don't want to ask me later, we do have now a better spatial array throughout the Sundarbans that's just now coming online. So it's quite great to get some of that data coming through. But as the purpose of what we're thinking about here, this carbon sequestration, we need to not only know what the sedimentation rate is of that platform area, but how much carbon is being deposited that could be either allochthonous or autochthonous, but also how much is being preserved long-term in that sediment column. So that's what we're going to bring to you all today. My student, Jeff Bomer, we used both surface elevation tables, marker horizons to get at some of the elevation dynamics, to look at inundation periods. So we were very interested in how much or how long the platform is being inundated. So this is hydro period, so that's a duration and a frequency kind of equation. We're using some shallow piezometers that are screened both at the surface and also within shallow groundwater. And then also took some core samples to about a meter depth. So we do have deeper core samples if folks are interested, but we're just going to show you data for the upper meter here. And we looked at some redox potential, loss on ignition for the organic content, and then went to Tracy's lab and she helped us do a CNH analyzer to really look at more of that organic carbon. This is a very busy plot. It's not important to go through it, but it's just to show surface elevation tables can give you a lot of information, millimeter scale changes in elevation. So we've got about 10 years now of those changes in elevation that have been happening at our sites over time. The vertical accretion, which is how much sediment is being deposited on these, what we call sediment tiles out there. And the important thing to bring to light to this audience is that there's an enormous amount of sediment that gets delivered during the monsoon season. On average, almost 3 centimeters per year. It's really incredible. And that's only over a few months. The piezometers really help us understand what's not only happening at the surface, but also in the subsurface. So again, I'm sorry for the busy plot here to the left, but the bottom one is showing us when our mangrove platform is being inundated and for how long. So these are calculations of the hydro period in terms of hours. The shaded regions are when it's the monsoon season. So certainly during the monsoon season, the mangrove forest is inundated for a much longer period of time. So 46% of the time, whereas during the dry season, it's only about 17% of the time. This middle panel is important because it shows the shallow water depth and what happens as the tide goes below the platform. So this dashed line here is the ground surface. So anytime those lines go below that, the groundwater table is actually lowering. So there's brought to light of, well, what's that doing to the subsurface? Is it oxygenating it? So we had a redox meter that we would bring out. Jeff would take seasonal core measurements both during the monsoon season and the dry season. So the dry season is shifted in blue or shown in blue here. So this is core depth. Redox potential is on the x-axis, where if it's more negative, that's more reducing conditions, more positive, that's more oxidizing conditions. So definitely in the upper 30 centimeters at least, because of that groundwater table lowering during the dry season, we're getting very oxygenated conditions in that region. Is that resulting in decomposition and not preservation of carbon that may have been deposited in that surface? Well, absolutely. So our loss on ignition data is shown here on the lower left, very low in terms of percent of organic matter. We've also got some bulk density information here shown on the lower right if you're interested, but you all are probably most interested in this total carbon and total organic carbon numbers. They're really low, and they're really low all the way down to a meter. In fact, they're much lower than the average for the Indo-Pacific region, which is usually about 7%. This was all less than 1% here. So one of the things that Jeff had mentioned in his paper is that he really thinks it's kind of a combination of both this lowering of the groundwater surface table, but then also that there could also be an export of this carbon that's happening during the monsoon season, where there's so much tidal inundation and it could be flushing some of at least the leaf litter out through that area. Okay, last slide. I'm gonna wrap it up here. Is just mention we not only have seasonal inundation or in vertical accretion rates, but long-term. And it's important to note whichever one you use, that could give you a different carbon sequestration rate. So if you're looking at short-term sedimentation from sediment tiles, you could say it's on parity with the world. But if we're looking at the longer term, what's in the core, it's actually a little bit lower than what's been reported elsewhere. Thank you.
Thank you so much, Carol.